Good morning, guys. My name is Carlo Amparo. I'm here to present a brief discussion about input-output interfaces and memory system. So let's start. Input-output interface provides a method for transferring information between storage and external input-output device. Input devices, a piece of computer hardware equipment used to provide data and control signals to an information processing system such as a computer or information appliances. Some examples of input devices are keyboard, mouse, scanner, and joystick. Output devices is any device used to send data from a computer to another device of a user. Some examples of output devices are monitor, printer, speaker, and headphone. Input-output bus and interface module. It defines the typical link between the processor and several peripherals. The input-output bus consists of data lines, address lines, and control lines. The input-output bus from the processor is attached. The control lines are referred as input-output command. The command are as follows. Control command is used to activate the peripheral and to inform it what to do. Status command is issued to test various status condition in the interface and peripherals. Data output command uses the interface to the respond by transferring data from the bus into one of its register. Data input command is the opposite of the data output. I/O processor. In the first method, the computer has independent sets of data address and control buses, one for accessing memory and other for input and output. Asynchronous transmission. Asynchronous transmission is a data between two units is a serial or parallel. In parallel, the data transmission message must be transmitted through separate conductor path. Modes of data transfer. Transfer of data is recognized between CPU and memory, or sometimes between any two devices or unit of your computer system. To transfer a data from one unit to another, one should be sure that both units have proper connection, and at the time of the data transfer is receiving unit is not so busy. Pipeline. Vector processing is a term used for the large class of techniques that are used to provide simultaneous data processing tasks for the purpose of increasing and computational speed of the computer system. Pipelining. Each segment performs partial proportion dictated by the way of task partitionally. Special characteristic of input and output. Devices allow data to be input and output between computer and the outside world. Like memory, we need to read to write memory, to provide address, and to read or write similarly for the input and output. Device registers. Each input and output has some number of devices register. Some types of registers are control register, data register, and status register. Control register used for CPU to specify what operation to do. Data register for holding data and from the CPU. Status register for showing status of the I/O device. When should we access device? First is a synchronous device. Device always becomes ready after a fixed number of processor. Clock cycles, processors should be right directionally. Asynchronous. No guarantees of device timing. Instead of device status register to indicate readiness. Requires processor to do some synchronization task to determine when devices is ready. Direct memory access. Direct memory access is device directly transfer data from the specified region in memory without the CPU intervention, so saves CPU time. Adds complexity to the memory system, designed typically used for bulk data, transfer from devices like disk and network interfaces. Universal Asynchronous Receiver Transmitter. The heart of any serial port is the Universal Asynchronous Receiver Transmitter or the UART chip. This chip completely controls the process of breaking the native parallel format and later converting serial data back into the parallel format. USB or the Universal Serial Bus. USB port are the peripheral bus specification that provides PNP or the plug and play capabilities from outside the computer case, which eliminates the need to install an expansion and to configure the system. IEE 1394 or the FireWire is another choice for the fast speed extreme devices. The IEEE 1394 bus was derived from the FireWire bus originally developed by Apple and the Texas Instrument. Allow up to 63 nodes, with each node is maximum of the devices in a chain. Memory system. The memory system serves as a repository of information, data in a computer system. It is a collection of storage location. Each storage location or memory word has a numerical address, a collection of storage location from the address space. Memory means the place where you have to store anything. This is very essential part of human being. Just like memory is also an important part of the computer system because we have to store some data or information. For storing these items, we need some memory or space. There are several different types of memory. The RAM, random access memory. This is the same as main memory. When used by itself, the term RAM refers to read and write memory. What is? You can both write data into RAM and read data from RAM. It is in contrast of ROM, which permits you only to read data. ROM or the read-only memory. Computers almost always contain a small amount of read-only memory that holds instruction for starting up to a computer. Unlike RAM, ROM cannot be written to. PROM, Programmable Read-Only Memory. A PROM is a memory chip on which you can store a program. But once the PROM has been used, you cannot wipe it clean and use it to store something else. Like ROMs, PROMs are non-volatile. EEPROM, Erasable Programmable Read-Only Memory. An EEPROM is a special type of PROM that can be erased by exposing it to ultraviolet light. The maximum size of the memory that can be used in any computer is determined by addressing scheme. Most modern computers are byte addressable. From the system standpoint, we can view the memory unit as a black box. Data transfer between the memory and the processor takes place through the use of two processor registers, MAR and MDR. There are three properties of memory that are inherently in conflict: the speed, capacity, and cost. In general, technology trades-off can be employed to optimize any two of the three factors at the expense of the third. Thus, it is possible to have memories that are large, cheap, but not fast, cheap and fast, but small, or large and fast, but expensive. Thanks for watching. Please like, share, and subscribe. Thank you.